Hi, thank you for coming. I'm James. This is Alex. We're engineers at Google. We're working on Firebase Studio, and we're going to talk to you a little bit today about Firebase Studio and AI-powered development. Sorry. Here's just a brief glance at the agenda we're going to cover for today. Let's just jump into the next. So you're cloning your repo, installing dependencies, and suddenly you're in the ninth circle of hell, right? It's a universal developer experience. We've all been there, staring at an error message that makes no sense because some package somewhere has a version conflict with another package that you didn't even realize that you were using. This is friction. This is setup tax. It's a silent killer of productivity, and let's be honest, our enthusiasm. And this leads us to the most infamous phrase in all of software development, that the last ditch defense, the shield we use when QA raises a bug. You know what I'm talking about. It's enough to even make a capybara lose his chill. But it works on my machine, right? Everybody's been there. We've all said it. We've all heard it. And while it's funny, it points to a fundamental problem. Our development environments are fragile, inconsistent, and a massive source of it works here, not there problems. This isn't just a meme. It's a symptom of a deep-seated issue in our workflows. But beyond setup, there are other obstacles to face. Every new app needs authentication, database connection, basic navigation. We write this scaffolding over and over. And now there's a new frontier, AI. We all want to build apps with generative AI. But that adds a whole new layer of complexity. How do we manage API keys securely? How do you wire up agentic workflows? It's another mountain of setup before you even write your first line of code. What if we could just skip the whole obstacle course? Enter Firebase Studio. Firebase Studio is an agentic cloud-based development environment that helps you build and ship production quality, full stack AI apps, including APIs, backends, front ends, mobile, and more. It's entirely web-based. Just visit a URL. And you're coding. It's built on Visual Studio Code. So it's not only incredibly familiar to most devs, but you can bring most of your existing preferences, extensions, and muscle memory to the web. Next slide. Now it's important to note, this is a full cloud VM, meaning you're not limited to things that run entirely in the browser. There's a Linux machine powering every Firebase Studio workspace. Now, one of the major challenges with developing on the web, especially for mobile apps, is actually testing out your app. So we've got a built-in Android emulator to go alongside with web-based previews. We've also got several Google integrations that make it easier to add APIs like Gemini and Google Maps to your app, and easier to deploy to the cloud with Firebase hosting to Cloud Run. And as just about every Google Surface in 2025, Gemini is built in. So you can get help understanding, generating, and improving code. There are also integrations that help you troubleshoot errors with AI and more. Finally, you can share your workspace with teammates. At the heart of Firebase Studio is a single file called dev.nix. If you're working on a team with other contributors, you can customize your environment precisely for your project and then commit your dev.nix file to your project's Git repo. That way, when a teammate imports the repo into Firebase Studio, their new workspace will have the exact same configuration as yours, complete with the same system packages, IDE extensions, starter scripts, and more. I really love how David East at Google puts it. Dev.nix is like a packaged JSON for your entire development environment. Dev.nix defines just about everything you need to work on your app and run it in the cloud. From system packages and services like compiler toolchains, to local database servers, to IDE extensions that add language support and debugging, to the specific wiring needed to boot up your front end and back end servers automatically so you can preview your app while you write code. It's all defined in one file. It's pretty sweet. Go to the next slide. Let's take a look at an example dev.nix file. It starts by specifying a Nix channel. Here, it's stable 24.11. Next slide. Using specific version here basically ensures reproducibility, so your dev environment will work just as well as in 2 years as it does today. Sorry, go back one. Next, we're setting a few environment variable. Wait, did I miss? Oh, I'm sorry. Yes, you were right. Next, we're setting a few environment variables. You can fine-tune your app's live preview integration, among other things. Remember, the dev.nix file is committed to Git, so be mindful of what you add here. Next are all the system packages that you want to install. Now, because Firebase Studio is based on CodeOSS, we support most extensions people would want. One caveat is that these come from the open source market, called OpenVSX, not from VS Code's official marketplace. Most extensions tend to be dually published to both marketplaces. Next, we have lifecycle hooks. OnCreate is run when a user first creates their workspace from a template, or when they first import their Git repo into Firebase Studio. It lets you do one-time setup, like running npm install or seeding data in your database. In my case, I'm also opening a file editor. The second lifecycle hook is onStart, particularly useful when running your app requires supporting your live preview. And speaking of which, this preview section defines the previews you want available to your app. Today, there are two kinds: an Android preview, which spins up an Android emulator, and one that we use here, a web preview, which boots up your app's HTTP server and shows it inside the embedded browser in the IDE. If you're building a framework or a library for others to use, you can include a dev.nix file in your sample code repositories so that when a user imports your samples into Firebase Studio, they can skip environment setup and jump straight into trying out your framework. You can even build your own custom template as an opinionated, customizable starting point for your users. One thing I want to show here, if you just go back a second, one thing I want to show here is you can easily add the Open in Firebase Studio button to your repository. And when you do that, when the user clicks the button, it'll launch the Firebase Studio IDE with your repo launched inside the Firebase Studio, so they're ready to go, pre-configured. Now, there's a lot more to dev.nix, so if you want to learn more, I'd strongly recommend watching David East's video on our blog. Now I'm going to hand it off to Alex to talk about Gemini.
Thank you, James. Gemini AI. Now let's talk about how Firebase Studio is integrated with Gemini. And we'll go through a few different options. Now, the first thing you see when you open an existing solution is front and center access to an agent, but it can go, which you can use to go much beyond just iterating or asking about code.
Start.
Let's try to play it like this. We're gonna see here what we can use the AI agent if we don't open an existing solution and instead we wanna start from the beginning. As you can see, we have a bunch of different templates, and you have really two ways to get started. You can either use a template and then iterate by adding your specific product configuration. And we see here all the standard ones that come bundled in. Of course, this is not everything. You can use GitHub templates provided by the community as well. Now, here we're just gonna use a very standard template, and we came up with a sketch on a napkin over the weekend for an app that we wanted to build together with my son. So here we're doing a math wizard that's supposed to help him with his school assignments, as well as just make it more fun. So we scanned that drawing. I'm gonna upload it here, and I'm gonna let Gemini know what I have in mind. So I want to do a math puzzle game. I'm not gonna tell an age range here for the sake of simplicity, but feel free to add as many details as you want. Generally, I like to start with a very brief prompt and run several parallel sessions, usually 3 is what I prefer, and then just look at the results, pick the winner, and go with that. Here is the result of running this prompt. You see a blueprint that was generated with some details on the feature that the AI believes to be useful for the idea that it presented. And below the feature list, there are style guidelines which define basic things like the color palette, which you can change, layout, and so on. Should you want to change anything, you can just go ahead and directly edit the blueprint, which is just a markdown file. We provide a convenient editor in here. Of course, after you generate the app, you still have all of this content inside of your solution, and you can later use it to iterate. But for now, we're just gonna go ahead and change one thing. We're gonna save. It looks good, so we're gonna go ahead and prototype this app. Depending on the requirements of your file, it might take a few minutes for the AI to go through all of the requirements. So now it's a great time. It would be a great time to go pick up a coffee and come back in a few minutes. In order to speed things up a bit, we fast forwarded here, and we're gonna go back to regular speed after we finish the generation. So here we see that the reasoning phase of the agent generation finished. So now it started to output code. And it started with the CSS file, implementing the color scheme. Now it's creating the game board, which is the thing that we had in that sketch. And you can see here is a list of all the edits that the AI agent is doing. And what happens under the hood is the agent uses a template. One of the templates that we saw earlier is, in this case, specially crafted Next.js template, and it's adapting it to implement the features that we prompted it. And after that, we see that it also saved the blueprint. It generated a few more files like the puzzle TS and the landing page. What will happen next? The AI agent will try to build the solution and will start a preview server. And since it was successful, you see it here. Should you encounter any errors, again, the agent will try to fix them for you, and it will prompt for assistance if it gets stuck anywhere on the way.
Next slide.
Next slide, yeah.
And space.
And space. Okay. All right. But once you finish generating something, that's only the beginning of the journey. You can simply switch between the prototyper interface, which we use to quickly generate the app, and the full code view, which is familiar from the previous slides, or if you used Firebase Studio before. On the left, you still have the source code. On the right, you have Gemini that you had before, as well as a live preview. And of course, you can rearrange your workspace the way you like it. In order to show you what would be the other way to use agentic AI to edit your app, we're going to do a simple change. We're going to first ask it to explain us what we did there. And then I think if we have time, we're going to do a simple change as well. So as you can see here, we didn't change the model. We keep it in the agentic way. So this way, we let the AI decide what it should do. It needs to come up with an explanation, with a plan, or it should just go straight and edit things. Sometimes you might want to take more control and steer it, but most of the time I find it easy to just ask things and let the AI decide how it wants to interpret my requests. It's good to ask one thing at a time, particularly if that's a complex question, or I would batch 2 or 3 different changes in one request, especially if they're related. So here I'm telling it to change the way the game will display the winning condition, and I have ways to ask for change. I could, of course, type, provide guidance by uploading an image. I could do both. And then later down the road, there'll be you'll be able to do to also change the model. If you want a simple change, you can switch to a faster model. So you have more of a flow, or you can keep the default 2.5 Pro for most changes, particularly until you get to have a feel about how the model behaves. So in this case, the model decided that everything it needed to change was just to replace a small piece for now. And then it's thinking, okay, what else should I do? So apparently it said, okay, I think it looks good. The model also agreed with that, so it stopped reasoning. Now, as we can see, we have a working app. We're gonna quickly test to see that the change was successful. Okay, good. And that's how I encourage you to work with AI all the time. Always test its changes to make sure it aligns with your vision, and always read the code, review the code if you understand the area of expertise where the model is operating. And if you don't understand that area of expertise, still give it a read and ask it questions. Why did that a decision that maybe it's not fully clear? A lot of times the model will self-steer back into where the optional or the optimal solution lies if you just ask it the right without having to tell it explicitly what to do. So that is a power tip here.
Oh, I started it.
We can. Do we have another? We have.
This is the third video.
Yeah, we have a third video. Yes. So we'll go and do one more change here. This time we're using the prototyper mode. So the one that we use to generate the app. As you can see, depending on what the work style you prefer, you have both options. So prototyper mode is more intuitive to people who don't plan to read the code too much, or when you're in full vibing mode, that is, you just want to quickly prototype something, you don't want to be distracted by reviewing the code. And this is great when you want to get to a version 0.1 quickly. Also, its interface is optimized for this specific workflow. We have here a visual annotation tool, which we just used in order to tell the model where we want the change done. And generally, it is just a cleaner flow for this specific use case. Both interfaces are interconnected, so your changes done here persist on the project. So there really is just a matter of taste for you, how you want to do this. I personally like to start here, move quickly, and the moment when I get stuck, or the moment when I feel like the model needs more guidance, I would switch over to the other mode, and I would just stay there for the rest of the project lifecycle. In this case, we asked again for a simple change, and the model updated the game board, as we can see in the preview. And again, I'm going to go ahead and test the change to make sure that nothing broke. No, as I believe that as time passes and both the models and us get better at these workflows, a lot of these will be a lot more seamless. But for now, I highly encourage you to test every single step. That makes a big difference between a solution that is launchable and a solution that is not. Important things to remember is after we finished with the UI and we like it, we wanted to take a look at the source code and check it for sanity, or ask a colleague of ours to do a code review before publishing it in production. It's very important since code reviewing culture has been around since a long time, and having an AI model generate the code doesn't change the fact that you always need to have a few pairs of eyes looking at the code before publishing. All right, now, how did we make it all this happen? I want to show you how we're steering the AI to generate what we want, and how you can customize Gemini in Firebase Studio using a simple configuration file, which is called AI-rules.md. Think of this markdown file as a set of instructions or a rule book for your AI. It defines exactly how you want Gemini to behave in natural language. And you can provide examples of responses or code snippets. This way you can tailor the output to match your specific needs, coding standards, especially important if you work in a team, and project requirements, which can be an important criteria when you operate in a certain constrained environment. This is incredibly useful because it provides consistency and quality in the AI-generated code, and it will also allow you to have repeatable results as you use the same process over and over under different circumstances and for different products. Now let's walk through an example. So here, I define a persona. In this example, I instruct the AI to act like Vulkan, logical, concise, and to the point. This means that AI will avoid conversational fluff and provide direct factual answers. You don't have to specify a persona, but if you find that you like a certain style of answering, it's good to tell the AI what is your way, your most efficient way of working. Of course, you can change it to anything else. My power tip here would be provide the minimal guidance for a style that makes you feel happy about the interaction with your AI. Next, we have some guidance that might be really important for your project. For instance, I want to always declare the type of variable and functions. Most of the time, the AI will do that for you. especially if you're working with TypeScript. But let's assume you have a project that has a mix of TypeScript and JavaScript, or some TypeScript has been migrated over, so it doesn't have all the type annotation. When the AI sees all that existing code having a different style from the best practice, it might decide to follow the existing style if it believes that to be important. It might not be aware that maybe you don't want to follow that existing style for the new code. Or maybe you do want to follow that style as to not confuse your colleagues. That's why it's so important whenever you see the AI misbehavior, or whenever you're personally not sure how you would treat something, to always have these guidelines here. And second one is the same. Usually to avoid any, well, on its own. But if you see this not happening automatically, just add the line. And the same is with any other libraries. When you use higher level abstractions like React, there's ways to do things. There might be multiple ways of doing the thing the right way. It's good to specify which style you prefer, especially when there's no examples in your source code that the AI will replicate, or when you're not referencing a file that has the correct style. Okay, now let's talk a bit about Firebase AI logic. It allows developers to directly call Gemini API from their mobile and web apps using the client SDKs. This enables features like AI chat experience, image generation, function calling, streaming input and output without requiring a backend. For more complex AI workflow, I would encourage you to use server-side logic such as GenKit, which is Firebase's open source framework, or if you are using an existing cloud environment, there are other great solutions like ADK and so on. Now let's take a look at an example of using Firebase AI logic in your app. So first, we will start by importing the dependencies and initializing the app. Next slide. So first we're importing the dependencies, and then we're initializing Firebase app. So far, it looks quite familiar here if you use Firebase before. And this is the specific way of Firebase. But again, it will look somewhat familiar if you used one of our generative SDKs before. Next, we will initialize a Gemini developer API backend service. And by backend service, we mean a service that connects to a Google backend, which will proxy your requests to the LLM of your choice. And after this, we would be creating a model connection. So this line here allows you to configure the provider or the backend do you want to use. Vertex AI, do you want to use Gemini API and so on. The next one allows you to decide which model you want to use. In our case, we're using Gemini 2.5 Flash because it's a fast and affordably priced model. And for our use case, for most of the use cases that I have in mind when prototyping things, Gemini 2.5 Flash is great during development. Next, we're going to define our prompt. Most of the time, I start with text prompts, and I would add other type of media as needed. Okay. And finally, this is the full program. Fairly standard result. Now here I'm using the generate content, which means I will only receive the final response when the generation finishes. I find it useful to start like this because it's the simplest to read code, but then stream results if the app doesn't seem too responsive. Please check out our documentation on how to do that easily, or you can also ask the AI to stream results for you. Now, if you want to output an image, which I encourage you to experiment with if you're building an app that is supposed to have dynamically generated graphics, that's how you do it. You would want to list both the text and the image modality for the response. The model will usually output what you ask it for, but you need to have text as well in case it needs to provide guidance or to ask for additional information. Otherwise, you have the same structure, model name, and the same way of calling generate content. Next slide. And finally, you want to make sure you treat the inline image data and display it however you want. As you can see, the request response format is quite flexible, and you can easily grow your app as your use cases become more complex. Also, you can reuse most of the code, much of the code, if you switch the underlying SDK, since this one, as well as GenKit, they would return your responses with parts inside. So it will feel very familiar when you're moving from one to another, depending on your use case.
Thank you.
Okay, thank you so much. We're here to take questions.
Yeah, if anybody has questions, happy to answer.
Either now or we can follow up at the booth.
Yeah, thank you very much.